Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello, everybody. This is Helge Hornes with Pepperl+Fuchs Plugged In. And today I have again Eduardo Bastillos with me. Hello, Eduardo.
Hello, Helga. Thank you for having me on today. I'm happy to be on again.
Anytime, Eduardo. You always bring important products, and today I think you're going to bring an important technology. It's really more a technology than a product.
Right. Well, my biased opinion, I bring the most important products, but that's just me.
Oh,
But
no, you're right. You're right. I tell you, you are correct. When I see customers, I like to say that without the inductive sensor, automation as we know it simply would not exist. And I truly believe it. That is not an overstatement.
oh, absolutely, absolutely. And in the true PNF fashion, we never stop innovating. We always try to come out with new technologies and are continuously improving on our current technologies. And today we have a fun one.
So what is it?
Today we're going to be talking about our sensors with active shielding. That's a unique technology to PNF, and yeah, I'm happy to talk about it today.
Yeah. So first and foremost, why don't you give us a little bit of an overview of what shielding is, and then talk about active shielding.
So you might have heard, or the listeners might have heard the terms flush mount, non-flush, embeddable, non-embeddable. Another word for that is shielded or unshielded. And what that really means is when inductive sensors are manufactured, before they leave the factory, they're sort of tuned to a specific range and a specific installation. And what active shielding does, it takes that same principle but applies it to our extended range limit switch sensors and our extended range rhinos. The main point of active shielding is that it gives you an incredibly stable sensing signal on the sensor.
Irrespective of how or largely independent of the mounting conditions.
Correct. Yep. Completely independent of the mounting conditions. And typically, what you'll see with inductive sensors in particular, especially the extended range ones, there's usually a bit of a trade off between having a longer range or having a stable signal. And with Pepperl+Fuchs Active Shielding proximity sensors, you don't have to make that choice. You get an extended range sensor with a very, very stable sensing field, regardless of how it's installed in the actual machine or application.
So I want to make one thing very clear, Eduardo, and that is not to scare anybody out there. So if you take a sensor and you put it in the installation into the system onto a machine and you follow our instructions, the output will be stable. There's no doubt about that. It's just that when all of a sudden you are faced with a scenario where there is some metal showing up in the vicinity of a sensor that's not the metal that you want to detect, then that output could get pre-dampened, and so the sensor is now able to trigger on much smaller changes. And active shielding, the way you explained it to us, it calculates, and calculates not the right word, it corrects out that environmental change so that the target is what triggers the sensor.
That's correct. So typically, in an inductive sensor, you have one sensing coil that basically, once a piece of metal enters that field, it disrupts the field, and then the sensor is smart enough to know, hey, there's a piece of metal in the field. What active shielding does, it has a second coil that is just detecting environment and just detecting the mounting conditions for that extraneous metal or that extra metal that you might see in the field that you might not want to detect that could disrupt the stability of the signal.
Yeah. So with having increased the stability beyond what all our sensors do anyhow, what does that do to the possible range these sensors get?
One really nice thing about these is you can sort of think of these as like an extended range Plus, for our rhinos or for our limit switch housing sensors, they have a longer range compared to their standard counterparts that don't have active shielding, and the actual sensing field is basically unaffected by any types of extra metals or any type of extra unwanted metals in the environment.
In what applications do you think this is particularly useful?
Basically, any type of application where the precision on the actual item being detected cannot be is not high enough to where the customer might want it. If you have a item where it may be bouncing, or maybe it's a very heavy item that it's really hard to get in the exact position every time, or maybe you have an item that is swinging or hanging or anything where the precision might not be to where you want it to be. And a sensor with active shielding can help eliminate that because it basically automatically compensates for the extra materials in the field, and you'll always have that stable range.
Okay. All right. Good. Eduardo, I think I want to give it a crack and summarize. And while I do that, you think about a 5-word statement that we can use to capture the main idea of today's conversation. So, Eduardo, what you were talking to us today about is a technology that enhances sensors that require more than just extended range. The technology is called active shielding, and it enables the sensor electronics to evaluate its mounting conditions and therefore provide higher stability. That is, the signal, the switching signal is more definitive even in unfavorable mounting conditions. And by doing that, we get more range out of a sensor than we would usually get with an extended range sensor, while not giving up the definitive nature of the output. So it's a reliable output when there is a target, and that output remains reliable even when things are not perfect in the mounting conditions. And having a sensor that gives us that much range for its size enables the solution of applications where the target doesn't follow a very precise path. So anything where you could have things bouncing around or swinging a little bit, we can now use this sensor and detect those objects reliably. How does that sound?
That's a great summary. Yeah, I think it's a very flexible and a very versatile sensor that can really help a lot of customers.
Good. So your turn. What are the 5 words you would like us to take away from today's conversation?
Okay, so I'm going to cheat again. I have 4 words, but I'm going to say adaptive precision without compromise. Typically, for an extended range sensor, you have to choose between long range or good stability. For active shielding, you don't have to choose. You get both.
Perfect. Eduardo, as always, thank you very much. Interesting technology, and I repeat it, no automation would be possible without the inductive sensor, and here's another way of making that even more reliable, more useful. Thank you very much, everybody. Thanks for listening to Pepperl+Fuchs Plugged In, and take care. Have a good day, Eduardo.
Thanks, Helga.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.